Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it. Hook. This one mistake cost more marks on last year's papers than any other transformation error. Students mixed up inside and outside changes and flipped the direction of the shift. Imagine losing a whole 3 marks because a plus K looked like a minus K. Stay with me. I'll give you a 10-second check that stops that exact error. That sounds familiar. I remember doing a whole sketch the wrong way round in a mock. Please tell me there's a quick fix. There is, but first, the concept. We'll go step by step through the 5 common changes you'll see. Y equals f of x plus k, y equals f of x plus k, y equals a f of x, y equals f of bx, and reflections like y equals minus f of x or y equals f of minus x. I'll use simple numbers and visual language so the rule actually makes sense. Start with y equals f of x plus k. This is a vertical shift. Add plus k and the whole graph moves up by k. If k is negative, it moves down. Think of lifting or lowering the whole picture. Every y value increases by k. Example, if f of 2 equals 3, then for y equals f of x plus 4, the new value at x equals 2 is 7. It's that simple. Every single y gets the same increase.
So, vertical changes act directly on outputs, the y's. Add after the function, move up, subtract, move down. Got it?
Now, the inside one, y equals f of x plus k. This is a horizontal shift, but it moves the graph by the opposite sign. If it's f of x plus 3, the graph shifts left by 3. If it's f of x minus 2, it shifts right by 2. Why? Because inside the function, you are changing which x gives the same output. Example, if f of 1 equals 5, then in f of x minus 2, the input x equals 3 will give 5, so the graph moved right by 2. Inside affects x values, and the sign flips. That's the common snag. That sign flip is the one that always tricks me. So inside equals horizontal, and the sign looks backwards. Note to self, don't trust the symbol, track the point. Exactly. Next, vertical stretch and compression. Y equals a f of x. If a is greater than 1, the graph stretches vertically. It gets taller. If 0 is less than a is less than 1, it compresses. Squash it down. Example, if f of 2 equals 3 and a equals 2, then a f of 2 equals 6. The y value doubles. If a is negative, you also get a reflection in the x-axis as well as the stretch or compression. For horizontal stretches and compressions, y equals f of bx. This one acts on x. If b greater than 1, the graph compresses horizontally. It gets squashed towards the y-axis. If 0 less than b less than 1, it stretches out. A useful way to think: replace x with bx means you reach the same inside value faster, so features move closer. Example, f of 2 equals 4. In f of 2x, the x that gave 2 before is now at x equals 1, so the graph halves in width. So, vertical ones change outputs, horizontal ones change inputs. Stretches with A affect Y, stretches with B affect X. Keep them separate. Simple language helps a lot. Finally, reflections. Y equals minus f of x flips the graph about the x-axis. Every y becomes its negative. Y equals f of minus x flips about the y-axis. Right becomes left. Combine these with stretches and shifts, but keep the order clear. Inside changes to x happen before horizontal stretches, and outside multipliers and additions act after.
Now, the exam technique. Here's where marks are awarded and where students lose them most often. Examiners want to see a clear statement of the transformation, a sketch or coordinates for at least 2 labelled points, and a brief justification or algebraic substitution if required. Typical split: M1 for identifying the correct transformation, M1 for applying it to a point or equation, and A1 for the correct final coordinates or sketch.
Can you give an example of a lost mark? What would lose that M1 or A1?
A very common error is writing f of x plus 3 as a shift right 3 instead of left 3. That loses the method mark because your statement of transformation is wrong. Another is failing to label points or axes on a sketch. If your sketch is unlabeled, an examiner may not award full A marks. Always label at least 2 transformed points, and if you've used algebra, write 1 clear substitution to show the method.
Also watch notation. Use f of x plus 2, not f of x plus 2 when you mean an inside shift. Small notation mistakes can lose marks because the examiner reads what you wrote, not what you meant. Write it down, don't just think it.
OK, that's a mental checklist. Name the transformation, show 1 substitution or move 2 points, label axes and points, and check signs. Anything else?
Quick win time. My 10-second sanity check. Pick a simple point on the original graph. In brackets 0, f of 0 or 1, f of 1 works well, and track that point through each algebraic step in order. Example, for y equals 2 f of x minus 3 plus 1, start with x equals 1. Inside, x minus 3 gives minus 2, evaluate f of minus 2, multiply by 2, then add 1. If tracking points mentally is hard, write the input-output chain. X reads to x minus 3, reads to f of dash, reads to times 2, reads to plus 1. If your final sketch matches the final coordinates, you're safe.
I love that. So instead of guessing the whole shape, test 1 or 2 points and see if they land where you expect. That takes 10 seconds and catches sign errors.
Second quick test, substitution check. After you find a transformed point, substitute its x into the transformed expression to check the y. If you've sketched or written coordinates, that one-line check often recovers silly arithmetic slip-ups and saves marks. Don't skip the check.
Worked example. Talk through and marking. Question. The graph of y equals f of x has a point 2, 3. Sketch the graph of y equals 2 f of x minus 3 plus 1 and give the coordinates of the image of 2, 3. Step 1. Identify transformations in order. Horizontal shift right 3, vertical stretch by 2, then up 1. That statement is worth M1.
Step 2. Track the point. Starting point is 2, 3. Horizontal shift right 3, x becomes 2 plus 3 equals 5, so intermediate point is 5, 3. Next, apply the vertical stretch. Multiply the y by 2 gives 5, 6. Then add 1, final point 5, 7. Write those steps down. Each one demonstrates method and wins marks. M1 for transformation statement, M1 for applying the horizontal shift, M1 for vertical stretch application, and A1 for the final coordinate. If you show the substitution, f of 2 equals 3 equals 2 times 3 plus 1 equals 7, the examiner can see your algebra clearly.
So if I just wrote 5, 7 with no work, I might lose a method mark. But if I show the chain 2, 3, 5, 3, 5, 6, 5, 7, that makes the method visible and secures the marks.
Exactly. That's why we say, write it down. Don't just think it. Last minute recap. Inside is horizontal and sign flips. Outside is vertical and sign keeps intuitive direction. Multiplication outside affects y. Multiplication inside affects x with inverse effect on width. Reflections flip axes. Use the 10-second point tracking sanity check and do a one-line substitution to verify.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find a downloadable one-page cheat sheet and worked solutions at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.
Thanks. I'll be tracking points from now on. Next time, will you cover circle theorems? That's another minefield. Yes, next episode we'll crack circle theorems and the 3 marks that make the difference. Credits produced by JC Academy Online. Stay curious and we'll see you next episode.